Shrink the Earth. Take everything. The Pacific, the Himalayas, every city, every road, every person who has ever lived. Press all of it down into a ball 1 millimeter wide, a grain of sand, small enough to lose in the carpet. Now build the rest of the sky at the same scale. The moon shrinks to a speck a quarter that size, circling about an inch away, close enough to touch. The entire Apollo program, the rockets, the risk, the farthest any human being has ever travelled, fits between your thumb and your finger. Then comes the sun. On this scale, it is a little over 4 inches wide. A grapefruit. You can hold it in one hand. You just can't keep it on the table. Because at this scale, that grapefruit has to stand about 40 feet away, across the room, through the wall, out in the yard, and between it and your grain of sand, nothing. 40 feet of empty air. That still feels manageable. A grain, a grapefruit, a backyard. You can picture it. Now ask where the next star goes. The nearest one. The very first stop beyond our sun. On this same scale, it breaks the model completely. To place it, you would have to leave the yard, leave the city, and keep driving until the road signs stopped making sense. Before this journey is over, that grain of sand will be measured against things no backyard on Earth can hold. Earth is much smaller than you think. Start on a beach. Any beach works. But make it the Pacific coast. Somewhere in California. Early morning. Nobody around. Stand at the waterline and look straight out at the horizon. That line where the water meets the sky feels infinitely far away. It is about 3 miles from your eyes. 3 miles. That is the entire visible world granted to a human being standing at sea level. Everything beyond it, which is nearly everything, hides below the curve of the planet. The ocean in front of you covers about a third of the Earth. The Pacific alone is larger than every continent combined. You could take all the land on the planet, every desert, every mountain range, every country, and drop it into the Pacific, and there would still be water left over. A jet leaving Los Angeles for Tokyo flies for roughly 11 hours, and for almost the entire flight. The view out the window is water, hour after hour after hour of it, at nearly 600 miles an hour, and the ocean just keeps coming. The land is no smaller in the way it feels. Drive west out of Beaumont, Texas at sunrise. Keep the speedometer at highway speed all day, and when the sun goes down you will still be in Texas. One state, and Texas fits inside the United States about 14 times over. And the United States is a piece of one continent among 6. A flight from New York to Los Angeles takes over 5 hours and covers around 2,500 miles. That feels like a serious journey. People dread it. They plan their whole day around it. It covers about 1/10 of the distance around the planet. To circle the Earth completely, you would travel roughly 25,000 miles. And if you tried to drive it at highway speed without ever stopping, without sleeping, without eating, the trip would take more than 2 weeks of continuous motion. The first people who actually did circle it paid a much higher price. In the year 1519, 5 ships left Spain under Ferdinand Magellan with about 270 men aboard, aiming to go around the world. The voyage took 3 years. Magellan himself was killed in the Philippines before it was half done. 4 of the 5 ships were lost. And when the last battered vessel finally limped home in 1522, 18 men were left alive on it. 18. Out of 270. For most of human history, that is what the size of this planet did to the people who challenged it. And your body knows all of this. Every instinct you have about distance was trained here. A mile is a long walk. 100 miles is a road trip. 1,000 miles means an airport. 10,000 miles is the far side of the world. So far that when you fly there, You land in a different day. Your entire sense of what the word big means was built by this planet, calibrated against its oceans and its continents, tested on its highways. That sense of scale works beautifully, right up until the moment you leave the surface. Here is what the rest of this journey looks like. We are going to walk outward from this beach, one step at a time, and at every step we will stop and compare the Earth to the next thing we find. The steps start small. They will not stay small, and somewhere along the way, the planet under your feet, the one that killed 250 of Magellan's men, the one that takes 2 weeks to drive around, is going to quietly slip below the threshold of what can even be drawn. The first step is the gentlest one, and it already breaks something. We only need to go as far as the moon. The moon is the most familiar object in the sky. Every human being who ever lived has seen it. You have watched it rise fat and orange over rooftops, seen it hang pale in a daytime sky, maybe stared at it through a cheap telescope and picked out craters. Of everything beyond the Earth, the moon feels like the one thing we actually know. It is the only other world with human footprints on it. So start there. How big is it? Really? The moon is about 2,160 miles across. Set it down gently on top of North America, and it would stretch from San Francisco to roughly Cleveland. That is a genuinely large object. A world in its own right, with mountains and plains and a surface area close to the size of Asia. Earth is nearly 4 times wider. About 50 moons would fit inside the Earth by volume. Put the two side by side, and our planet looks comfortably dominant. A basketball next to a baseball. Nothing about that comparison feels alarming. If the story stopped at size, the moon would be a footnote. The story does not stop at size. The part that ambushes people is the gap. Every picture of the Earth and moon you have ever seen. In classrooms, in textbooks, in movies, shows them practically touching. 2 friendly neighbours sharing a frame. Those pictures all quietly squeeze the distance to make the shot fit. And the squeezing has hidden the best part. The moon orbits about 239,000 miles away. You could line up 30 Earths in that gap, one after another, edge to edge, and just barely bridge it. It gets stranger. Take every other planet in the solar system. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all of them. Line them up edge to edge like beads on a string. Giant next to giant. And the entire collection fits in the space between the Earth and the moon. With a couple thousand miles to spare. Every planet we will meet in the next several chapters, every world humanity has ever photographed up close, fits inside the gap you look across every night without noticing it. 3 human beings once crossed that gap for the first time, and one of them left us the perfect measurement of what it does to the Earth. In December of 1968, the crew of Apollo 8, Frank Borman, Jim Lovell, and Bill Anders, became the first people in history to leave Earth entirely and travel to another world. It took them 3 days of continuous falling through blackness. When they finally swung around the far side of the moon and looked back, Lovell held up his thumb against the window, closed one eye, and discovered that his thumb covered the Earth. Completely. Every ocean, every continent, every war, every person he had ever met. Hidden behind one thumb, Anders raised a camera and took the photograph the world now calls Earthrise. A small blue marble floating over a dead grey horizon. And people back home, seeing their planet from the outside for the first time, understood something no map had ever managed to teach. 239,000 miles did that. 3 days of travel. And the Earth became small enough to hide behind a thumb. Now put that distance in the terms this journey will keep using, because miles are about to stop being useful. Light is the fastest thing that exists. Nothing in the universe outruns it. A beam of light leaving the moon reaches your eyes in about 1 1/3 seconds. When flight controllers in Houston spoke to the Apollo crews, their words took over a second to arrive, and the answers took over a second to come back. A tiny hesitation riding on every conversation. The first faint hint that space runs on delays. 1 1/3 seconds. Hold on to that number. It is the farthest any human being has ever been from home. The outer boundary of our species' entire travel history. And it is about to become a rounding error, because to see what comes next, we need to do something drastic to the Earth. We need to shrink it. Clear off a kitchen table. We are going to build the solar system on it. And we are going to build it honestly, which is the part nobody ever does. Every model you have ever met solves the same problem the same way. The posters on classroom walls, the plastic models with planets on metal arms, the graphics in documentaries, all of them shrink the planets and then quietly keep the distances wrong. Because a model with honest distances will not fit on a poster. Today we build the honest version. One scale, applied to everything. No exceptions. Start with the Earth. Take the whole planet. The Pacific that outweighs the continents. The Texas that takes a day to cross. The 25,000-mile waistline that broke Magellan's fleet. And compress all of it into a ball 1 millimeter wide. A grain of sand. Set it down in the middle of the table. Some things vanish immediately. At this size, Mount Everest is far too small to feel. The Mariana Trench, the deepest wound in the ocean floor, is gone, scaled down like this. The Earth is smoother than a marble, its greatest mountains and canyons fainter than the polish marks on a ball bearing. The entire realm of human adventure, every summit ever climbed, every depth ever reached, is now surface texture too fine to detect. Human spaceflight shrinks with it. The International Space Station, our permanent outpost in space. The place astronauts describe as being up there, orbits about 250 miles above the surface. On the table, that puts it a 50th of a millimeter above the grain. Every astronaut of the last half-century has lived and worked closer to the grain of sand than the width of a human hair. Now, add the moon. It becomes a speck, a 1/4 of a millimeter wide. A crumb of dust, orbiting about 1.25 inches from the grain. Reach out and frame both between your thumb and forefinger. You are now holding the complete travel history of the human species. Apollo 8's 3-day crossing, Lovell's thumb, Earthrise. All of it happened inside the pinch of your fingers. The table still feels calm. A grain, a speck, 1 inch of air. You can see everything at once, and everything makes sense. Enjoy that feeling, because we are about to add the sun, and the sun has never fit inside anyone's kitchen. Size first. The sun is about 109 Earths wide. On our scale, that makes it a little over 4 inches across. A grapefruit. Pick it up. Feel the heft of it in one hand. 109 grains of sand, lined up in a row. To cross one piece of fruit, already the Earth is demoted. From the centre of the model to a fleck beside it. But the size is the small surprise. The real surprise is where the grapefruit has to stand. At an honest scale, the sun sits about 40 feet from the grain of sand. Walk it off. Across the kitchen, down the hallway, through the front door, out onto the lawn. Turn around and look back at the table. Somewhere in there, invisible from where you now stand, is a grain of sand with a dust speck circling it. And that grain is everything. Rome, the dinosaurs, the Pacific, your entire life. From the grapefruit's position, the Earth cannot be seen at all, and between them, this is the part to actually feel. There is nothing. No fence, no landmarks, no stops along the way. 40 feet of empty air, which in the real universe is 93 million miles of vacuum. a distance so wide that Earth itself, the planet that takes 2 weeks to drive around, dissolves into it like a grain dropped into a canyon. Light itself gives you the measure of it. In the real universe, sunlight crosses that gap in 8 minutes and 20 seconds. Here is what that means on our model, and it may be the strangest fact on this table, scaled down along with everything else. A beam of light travels about 1 inch per second. You could race a sunbeam down the hallway at a slow, casual stroll, and win. The fastest thing in existence, the absolute speed limit of the universe, crawls across the kitchen like a bug, and it still needs over 8 minutes to connect the grapefruit to the grain. So take inventory, because right now, at this station on the journey, everything is still holdable. Earth is a grain of sand. The moon is a speck an inch away. The sun is a grapefruit standing one long hallway from the table. The scale works. Your mind can wrap around all of it. There is a version of this story where it stays that comfortable, where the whole universe politely arranges itself across a house and a yard. That version does not survive this video. It has a few chapters left to live. First, though, walk back down the hallway and pick up the grapefruit again, because we owe it a closer look. Everything else on this table, the grain, the speck, all the beads we are about to add, every one of them is leftover crumbs from a construction project. The grapefruit is the construction project, and the numbers inside it are about to make the Earth feel smaller than any distance ever could. Hold the grapefruit up to eye level, because it has been fooling you your whole life. From the beach in Chapter 1, the sun looks small, a bright coin, about the same size in the sky as the moon, something you could blot out with your thumb held at arm's length. Human beings stared at that coin for 100,000 years without any way of knowing what it actually was. It rises, it sets, it warms your face on a cold morning. It feels like a feature of the sky. The way a lamp is a feature of a room, here is what the coin really is. If the Earth were hollow, you could pour roughly 1.3 million Earths into the volume of the Sun. 1.3 million. And a quick note of honesty here, because this journey has promised not to cheat. That figure compares pure volume, the way you would compare 2 amounts of water. Real spheres do not pack together perfectly. So, if you were somehow stuffing solid Earths into a hollow sun, like gumballs into a jar, the number would come out lower. Either way, the shape of the truth is the same. Our planet is not small next to the sun. It is negligible next to the sun. Try to actually count that high and the number fights back. If you counted 1 Earth every second, no sleeping, no stopping, filling the sun would take you about 2 weeks. Every second. Another entire planet. Another Pacific. Another full copy of every mountain and city and human being. And after a full day of that, you would have thrown in 86,000 Earths and barely started. Sunspots make the point with pictures instead of arithmetic. Those dark freckles that appear on the sun's face, the ones astronomers have sketched since Galileo, look like blemishes. Tiny flaws on the surface. Many of them are wider than the entire Earth. Our whole world could sink into one of the sun's passing skin blemishes and never touch the sides. Now weigh it, because the mass is where Earth truly loses its seat at the table. Add up everything in the solar system, every planet, every moon, every asteroid, every comet, every speck of dust and wisp of gas, the whole inventory of everything that orbits. The sun accounts for about 99.8% of all of it. Sit with that split for a second. The sun is not just the biggest member of the solar system. The sun essentially is the solar system. Everything else, all 8 planets, all the hundreds of moons, all the billions of rocks, splits a leftover 0.2% between them, and of that leftover, Jupiter and Saturn take most of it. Earth's share of the solar system, by mass, works out to about 3 parts in a million. If the solar system were a 2,000-pound pickup truck, the sun would be the truck, and the Earth would be a fraction of one of the door hinge screws. The strangest part is that this overwhelming object is not a thing in the way a planet is a thing. The sun has no surface. There is nothing to land on, nothing to touch. It is a ball of plasma so massive that its own gravity crushes its core to a density and temperature where hydrogen atoms slam together and fuse. And that fusion converts about 4 million tons of matter into pure energy every single second. 4 million tons. Every second. For 4.5 billion years. With enough fuel remaining to keep going for billions more. The warmth on your face at the beach is a piece of the sun's own mass. Disassembled into light. Delivered across 93 million miles. Arriving 8 minutes late. That is the grapefruit at the end of the hallway. A self-burning furnace holding 99.8% of everything. So large that 1 million copies of our world rattle around inside it like sand in a drum. You would think an object like that ends the conversation about size. It does not. And the reason is waiting inside the 0.2%. Because the scraps left over from the sun's formation were not divided evenly. One of the leftovers grabbed more than twice as much as all the others combined. Grew into a giant with a permanent storm bigger than our planet, and earned itself a middle rung on the ladder we are climbing, before the sun cuts it down to size. Meet the king of the scraps. Every scale needs a middle rung, and Jupiter is ours. Go back to the table and add it to the model. On our scale, Jupiter is a ball about 11 millimeters wide. A marble. Set it down and look at the lineup so far. A grain of sand. A dust speck. A marble. And down the hallway. A grapefruit. That marble is the largest planet that exists in our solar system. And before we shrink it back down to size, it has earned one honest look at full glory. Jupiter is about 11 Earths wide. By volume, you could pour more than 1,300 Earths into it. It outweighs every other planet in the solar system combined. More than twice over. Take Saturn, Uranus, Neptune, Earth, Venus, Mars, Mercury, every moon, every asteroid. Throw them all on one side of the balance and Jupiter alone on the other. And Jupiter wins easily. Within the leftover scraps of the solar system, it is the whole show, with everything else as a rounding error, which should sound familiar, because that is exactly the relationship the Sun has to Jupiter. The pattern repeats. One level down, the planet even carries its own permanent monument to scale. That famous red eye in every photograph of Jupiter is a storm. The Great Red Spot, a hurricane that has been spinning since at least the 1800s. With winds in the range of 300 to 400 miles per hour. Astronomers were sketching a spot on Jupiter before the American Civil War. And the storm is still turning right now. Tonight, as you watch this, and that one storm, that single weather event, is wider than the entire Earth. Our planet could be dropped into Jupiter's eye, swallowed by a patch of bad weather. Without the storm having to widen, now carry the marble down the hallway and hold it up next to the grapefruit. It is 1/10 as wide. 1/10. The king of the planets. The giant that outweighs all its siblings put together twice over. The world whose weather could inhale our world. Stands next to the sun the way a marble stands next to a grapefruit. And the grapefruit could hold about 1,000 of it. All that royalty from the last few paragraphs evaporates in one side-by-side glance. Jupiter turns out to be just the biggest crumb. Feel the whiplash of that. Because the whiplash is the lesson. Earth looked enormous until the moon gave us distance. Jupiter looked enormous until the sun stood next to it. Every rung of this ladder feels like the top while you are standing on it. And every rung becomes a footnote the moment you climb one more. That pattern has now repeated twice. It is going to keep repeating. And the next time it happens, it will not be an object that does the humbling, because here is the turn in the road. and it changes the character of everything that follows. From this point outward, the objects stop mattering. We have now met the biggest planet and the star that dwarfs it. And in terms of sheer stuff, the solar system has nothing larger left to show you. What it has left to show you is the space between the stuff. Put the marble in its proper place on the model. About 200 feet from the grapefruit, most of a city block away, and notice how lonely it suddenly looks out there. Then get ready to walk, because the next chapter is not about a thing at all. It is about the nothing, and the nothing is the biggest thing we own. Do something strange for me. Take every picture of the solar system you have ever seen. The classroom poster with the planets lined up shoulder to shoulder. The screensaver with the neat coloured orbits. The museum mobile hanging from the ceiling. And set them all aside. Every one of them was drawn under the same impossible constraint. Shrink the planets. Keep the gaps. And the picture fits on a wall. Shrink the gaps too, at the same honest scale, and the picture stops existing. Here is that constraint in numbers. Draw the solar system at one honest scale, with planets big enough to see, and the paper needs to be the length of a football field. Print it on a normal poster instead. And at honest scale, every planet becomes an invisible dot, and the poster becomes a blank sheet. So every artist who ever drew the solar system faced a choice between a picture that fits and a picture that is true. And they all chose the one that fits. And 3 generations of us grew up with the wrong map in our heads. An honest map of the solar system is a picture of nothing. Today we own a football field's worth of honest map. So let's walk it. The grapefruit sun stands at one end zone. Go. The first 3 steps of the journey come fast. Or at least they feel fast. Mercury is a grain smaller than Earth. About 15 feet out. Venus, almost exactly an Earth-sized grain, sits at 28 feet. Our Earth, the star of this whole story, waits at its familiar 40 feet with its dust speck moon an inch away. Mars, half a grain, sits at about 60 feet. There, 4 planets, the entire rocky family, every world where humans have landed machines or ever seriously dreamed of walking, all inside the first 60 feet. This is the crowded part of the solar system. This is downtown. Notice what your footsteps cross between those grains. Air, empty table, empty floor, empty field. In the real universe, that emptiness is tens of millions of miles of hard vacuum, and nothing so complete that it outclasses the best vacuum chambers on Earth. The planets are not neighbours with fences between them. They are lighthouses on separate seas. Keep walking, and now the journey changes character. The steps stretch. Jupiter, our marble, does not show up until 200 feet, 2/3 of a football field from the sun, with nothing in between except a thin scatter of asteroid dust, too fine for our model to even represent. Saturn, a slightly smaller marble, arrives at 370 feet, already past the far end zone of an American football field. Uranus, a ball bearing of 4 millimeters, waits at 740 feet, 2.5 football fields out. And Neptune, the last planet, another ball bearing, finally appears at about 1150 feet from the grapefruit, nearly a quarter of a mile. Stop at Neptune and look back down the whole walk. A quarter mile of ground. Now, inventory everything you passed. A grapefruit, 2 marbles, 2 ball bearings, 4 grains of sand, a few dust specks for moons. That is the complete list. You could sweep the entire physical solar system into a coffee mug, then set the mug down at one end of a quarter mile of open ground. And this model would still be truthful. All of the matter, everything the sun's gravity holds in the planetary neighbourhood, gathers into a handful of crumbs sprinkled across a walk that would take you 5 minutes. The emptiness even explains something you may have wondered about spacecraft. When missions fly to the outer planets, they cross the asteroid belt. And in the movies, an asteroid belt is a boulder field where the hero dodges tumbling rocks. Real engineers have the opposite problem. When they fly a probe through the actual asteroid belt, the odds of accidentally passing near anything at all are so small that if they want a close look at an asteroid, they have to steer for one deliberately. And even then, the targeting takes years of planning. Our machines cross the busiest debris field in the solar system and reliably meet nothing. Because there is nothing. Spread across distances that make collisions a stroke of luck. The sun itself surrenders out here. Stand on Neptune and our star shows no disk to your eye. Just a very bright point, delivering about 1/900th of the light that falls on a California beach. High noon on Neptune is a deep, silvery twilight, roughly the mood of Earth a few minutes after sunset. The lamp of the solar system, the furnace holding 99.8% of everything, has faded to a cold spark that could not warm your hands. So here is the honest portrait of our home system, the one no poster will ever manage to print. It is a 1/4 mile of vacuum with a piece of fruit at one end, and the fruit's gravity, thinning with every step but never letting go, holds a few crumbs in slow, patient circles. The crumbs are so far apart that each one lives functionally alone, a private world in a private ocean of black. Earth is the third crumb, 40 feet out, invisible from every other crumb without a telescope, standing at Neptune, a 1/4 mile from the grapefruit. Every instinct you have says the walk is over. The last planet is behind you. The map in your childhood bedroom literally ended here. At the 8th orbit, with maybe a small apologetic dot for Pluto. Surely this is the edge. Here is the uncomfortable truth we have to deal with next. Walk past Neptune and the solar system does not end. It refuses to end. It keeps going, and going, and the harder scientists try to draw the final boundary line, the further it slips away from them, until the very question of where our home ends turns out to have 3 different answers. And the third one is so far out there that it bumps into the neighbours. The edge is not a line, and the story of why is the last thing standing between us and the stars. Every map of the solar system you grew up with made you a quiet promise. It promised that the thing had an edge, 8 orbits, maybe a dot for Pluto, and then the paper ran out, and the running out felt like an answer. Past this line, nothing. End of neighbourhood. Ask a scientist to actually draw that line and watch the trouble start. Because it turns out our solar system has at least 3 edges, and they disagree with each other by a factor of thousands. The first edge is the one you already walked. Call it the planetary edge. The orbit of Neptune. A 1/4 mile out on our model. Past Neptune the true planets stop, and for a long time that felt like the natural place to end the story. It is not. This channel has spent entire journeys out in the country beyond Neptune, the frozen belt Pluto lives in. So we will not retell that story here. For today, one sentence covers it. Past the last planet, there are millions of small icy worlds, spread across a region wider than everything we just walked. And even they are nowhere near the exit. The second edge belongs to the sun's breath. Our star does not just shine, it exhales, constantly. A thin hurricane of charged particles called the solar wind, blowing outward past every planet and inflating an enormous bubble in the gas between the stars. Inside the bubble, the sun's weather rules. Outside it, the space between the stars begins. The wall of that bubble is a real, physical, measurable boundary, and one machine built by human hands has crossed it and lived to report back. That machine deserves a proper introduction, because it will be our yardstick for the rest of this journey. Voyager 1 left Florida in 1977, the same summer Star Wars opened in theatres. It is the most distant spacecraft our species has ever flown, racing outward at about 38,000 miles per hour, a speed that would carry you from New York to Los Angeles in under 4 minutes. It has been flying, without a single day off, for nearly 50 years. In August of 2012, after 35 years of continuous travel, Voyager 1 finally punched through the wall of the Sun's bubble, and its instruments felt the change. The Sun's wind dying away behind it, the cold gas of interstellar space pressing in around it. Newspapers around the world ran the same headline: Voyager leaves the solar system. The headline was wrong, and the way it was wrong is the whole point of this chapter. Find Voyager 1 on our model. The grapefruit stands at one end. Neptune's ball bearing sits a quarter mile out. And Voyager 1, after half a century at 38,000 miles per hour, has made it about a mile and a quarter from the grapefruit. A mile and a quarter. A lifetime of flight at 40 times the speed of a rifle bullet. And on the honest map, humanity's farthest traveller is a 25-minute walk from the Sun. And here is why the headline oversold it. Crossing the bubble means leaving the Sun's weather. It does not mean leaving the Sun's grip. Gravity does not stop at the bubble wall. The Sun's pull reaches on, thinning but never quitting. And it holds objects in orbit far, far beyond anywhere Voyager has reached. The comets that occasionally fall into our sky come from a vast cloud of icy bodies believed to surround the entire solar system, so distant that the Sun holds them only barely. And that cloud, not the bubble, marks the third edge, the gravitational edge, the true property line of our star. Put the third edge on the model and the model starts to sweat. The bubble wall sat about a mile out. The far boundary of the Sun's gravitational kingdom lies not 1 mile out, not 10, but on the order of hundreds of miles from the grapefruit. On the real map, that is a substantial fraction of the distance to the next star. Our Sun's legal property, the region where its gravity is still the loudest voice, extends so far that the question, where does the solar system end, and the question, where does the next star's territory begin, almost share an answer. So the childhood map failed twice. It ended the solar system 1,000 times too early, and it drew an edge where nature drew a fade. There is no wall out there, no line, no sign. The Sun's kingdom just thins, mile after million miles. Planets giving way to ice, ice giving way to the faint far comets, until somewhere in the black, its whisper of gravity finally drops below the whisper coming from the other direction, which raises the only question left. The other direction. We have stretched the solar system as far as it can possibly be stretched. Hundreds of miles on a model that started on a kitchen table. Surely, at these distances, we have earned the next landmark. Surely the nearest star is close now. The next chapter is the reason this video exists. Take a breath before you start it. The nearest star to our Sun is called Proxima Centauri. The name literally means the nearest one of the Centaurus constellation. And astronomers were not being poetic. Out of hundreds of billions of stars in our galaxy, this small red star is the single closest neighbour we have. Whatever the gap between our star and the next star turns out to be, this is the smallest possible version of it, the best case, the shortest interstellar distance we will ever be offered. Here it is. Proxima Centauri sits 4¼ light-years away, which comes out to about 25 trillion miles. 25 trillion is a noise, not a number. Nobody's brain does anything useful with the word trillion. So let's do what we have done all along, and put it on the model. And I want to set the scene properly first, because we have been building toward this moment for 8 chapters. Remember the state of the table. The Earth is a grain of sand. The full quarter-mile walk from the grapefruit to Neptune covered the entire planetary system, even the wildest version of the solar system, the third edge. The outermost gravitational holdings of the Sun dragged the model out to a few hundred miles. To contain the whole kingdom of our star, we already had to grow the kitchen table into something the size of a state. Now place the next grapefruit. At the scale where Earth is 1 millimeter, Proxima Centauri lands about 2,000 miles away. 2,000 miles. If our grain of sand sits on a table in New York City, the nearest star in the universe is somewhere past the Rocky Mountains. To carry the model from one star to the next, you would leave the table, leave the building, drive west through New Jersey and Pennsylvania, through Ohio, Indiana, Illinois, across the entire Mississippi River basin, through the Great Plains, day after day of interstate at 70 miles an hour, and somewhere out beyond Denver you could finally stop the car, walk into a field, and set down the second piece of fruit. Then look at what your drive contained. For the first 40 feet of that road trip, you passed the entire orbit of the Earth. Within the first quarter mile, you cleared every planet the Sun owns. Within the first mile and a half, you passed Voyager 1, the farthest machine our species has ever flown. And then came the rest. 1,999 miles of nothing. No planets. No landmarks. No light. Just a few stray atoms per thimble of space. Emptier than any vacuum a laboratory on Earth can manufacture. All the way to the far grapefruit standing alone in its field. That is the true shape of our situation. Everything we have ever known. Every world. Every mission. Every map is a coffee mug of crumbs at one end of a transcontinental highway of vacuum. Let Voyager measure it for you. Since Voyager is out there right now making the attempt. Its speed, remember, covers New York to Los Angeles in under 4 minutes. It has flown since 1977 without stopping. If it were aimed at Proxima Centauri, which it is not, but if it were, the trip would take it more than 70,000 years. Say that number slowly. 70,000 years ago, there were no cities, no farms, no writing, no wheels. Woolly mammoths grazed on the plains of Europe. Our species had not yet reached the Americas. If people alive back then had launched Voyager, it would be arriving at the nearest star about now. Having flown through the entire recorded and unrecorded history of civilization, and every single mile of the journey would have been empty. And I want to be clear about what that 70,000-year figure means, because it is easy to hear it as an engineering complaint, as if we just need faster rockets. Build a rocket 10 times faster than Voyager, and the trip still takes 7,000 years. Longer than the age of the pyramids. 100 times faster. 700 years. A voyage begun in the Middle Ages arriving today. The problem was never the vehicle. The problem is that the distance between stars belongs to a different category of size than anything in human experience. And no intuition trained on oceans and highways survives contact with it. Which brings us to the end of something. Because our model just failed for the first time. The 1 millimeter Earth has served this story faithfully. It shrank our planet to a grain, and the grain stayed visible. It pushed the sun down a hallway, and we walked the hallway. It stretched the planets across a quarter mile, and we walked that too. But no scale model survives its first interstellar distance. The grain of sand was never the problem. The problem is that once the nearest star enters the frame, the model needs a continent to stand in. And a model the size of a continent teaches nothing. You cannot see both grapefruits at once. You cannot see anything at once. The tool that carried us for 6 chapters just died in a field outside Denver, on the very first step into the wider universe. Here is what should actually stay with you as we let it go. This was the shortest distance, the single closest star, the kindest gap the universe had to offer, and it outgrew a scale model that had comfortably swallowed the entire solar system. Every distance from here on out is larger, and most of them are larger by amounts that will make this chapter look gentle. To go on, we need new equipment, a new kind of number, one built for this territory, one that folds 25 trillion miles into a phrase you can say in a second. The equipment exists. You have heard its name your whole life. Almost nobody ever stops to feel what it really does. Light is the fastest thing reality permits. In 1 second, a beam of light covers about 186,000 miles, enough to lap the Earth 7.5 times. Nothing outruns it. Nothing ties it. And the universe enforces that speed limit without exceptions and without appeals. A light year is simply the distance that unbeatable speed covers in a year of non-stop travel. Just under 6 trillion miles. And the honest way to understand the unit is to walk back through our journey and let light remeasure everything we have seen. Start at the beach from Chapter 1. Light circles the entire planet. The 25,000-mile waistline. 2-week road trip and all. In about 1/7 of a second. At light speed, the Earth is a blink. Step out to the Moon. The gap that held 30 Earths. The 3-day crossing of Apollo 8. Light does it in 1 1/3 seconds. The number I asked you to hold on to in Chapter 2. Say the phrase, 1 Mississippi, and a photon leaving the Moon is already arriving in your eye. Stretch to the Sun. 40 feet of hallway. 8 minutes and 20 seconds. Long enough to make coffee. No more. Cross the whole planetary system. Out to Neptune. The 1/4-mile walk. The map of your childhood bedroom. A bit over 4 hours. Sunlight that warmed a California beach at breakfast is dusting the last planet before dinner. Reach farther. Out to Voyager 1. 50 years of flight. The farthest machine of the human species. Light catches it in less than a day. Now aim at Proxima Centaur. And watch the unit finally strain. Hours will not cover it. Days will not cover it. Weeks. Months. Still no. The beam flies on through year 1. Everything on Earth aging around its journey. Through year 2. Through year 3. Through year 4. And partway into the 5th year it finally arrives. 4.25 years. For the fastest thing that exists. Running flat out the entire time. To reach the closest star there is. That is what a light year actually measures. And notice what happened to the numbers along the way. The Moon was seconds. The Sun was minutes. The planets were hours. The stars begin at years. Each rung of our ladder lives in its own unit of time. And the gaps between rungs are not gaps between big numbers and bigger numbers. They are gaps between kinds of time. Human distances fit inside a heartbeat. The solar system fits inside a workday. The stars demand years of the fastest traveller reality allows. And everything beyond the stars, as we are about to see, demands lifetimes, then ages, then spans that swallow the whole story of our species. There is one more thing folded inside this unit, and I want to plant it here, because near the end of this journey it becomes the key to the biggest number in this entire story. If Proxima Centauri is 4.25 light years away, then the light entering your telescope tonight left that star 4.25 years ago. You are not seeing Proxima as it is. You are seeing it as it was. 4 birthdays back. Distance and delay are the same thing out here. Every look outward is a look backward. And the farther we aim, the older the news becomes. Tonight, that is a curiosity. Hold on to it anyway. So take stock of the expedition. We own a proper unit now, one sized for the territory, and we have officially arrived at another star. The first genuine landmark beyond home. The destination that cost 70,000 Voyager years and outgrew our beautiful model. We have finally reached another star. And here is the truth I have been saving. On the map of what comes next, we have barely moved at all. We need a new model, and this time the Earth does not get to be the star of it. Take a quarter out of your pocket. 1 American 25-cent coin. A little under an inch across. That coin is now the entire solar system. All of it. The full 1/4-mile walk from Chapter 6. The grapefruit and the marbles and the ball bearings. The whole planetary kingdom out to Neptune's orbit. Pressed into a disk you can hide under your thumb. Every place ever photographed by every space probe. Every world ever named by every civilization. Every mile of every mission NASA has ever flown is on that coin. Set it down on the sidewalk. That is the new unit of everything. The old model deserves a proper reading of its own numbers inside the new one. The grapefruit sun that stood at the end of a hallway is now a dot in the coin's center about 4 microns wide. The size of a bacterium, 20 times finer than a human hair. Jupiter, the king that outweighed all its siblings twice over, is far below anything an eye could find. Voyager 1, still flying, still faithfully calling home after 50 years, has travelled slightly less than 3 inches from the coin, half a century at 38,000 miles an hour. And on this scale it has not yet crossed your shoe. And the Earth. I promised at the start of this journey that our planet would eventually slip below the threshold of what can be drawn. And this is the place it happens. On the coin model, the Earth measures about 30 nanometers, which is the size of a small virus. There is no ink fine enough to print it, no printer precise enough to place it, no human eye that could ever confirm it was there. The main character of this entire story, the planet with the Pacific and the Himalayas and 8 billion people on it, just became physically impossible to include in its own movie. Take a moment with that, and then we move on. Because the model has work to do. Here is the payoff. The reason we built this thing, on the grain of sand model, the nearest star sat 2,000 miles away. A road trip across America. We have just shrunk the entire solar system by a factor of thousands. Crushed a quarter mile of planets into a quarter. Surely we have tamed the distance to Proxima Centauri. Here is what we tamed it down to. With the solar system as a coin on the sidewalk, Proxima Centauri is another coin about 350 feet away. A football field, plus both end zones, plus a little more. Walk it. A full minute of steady walking down the block. Past parked cars, past doorways. And there on the pavement is the second coin. The next star system, with its own microbe of a sun in the centre and its own invisible specks for planets. Between the two coins, running the entire length of that block, nothing. That is the trade the universe just forced on us. To make the gap between stars walkable, we had to pay with everything else. The planets are gone. The sun is a germ. The Earth does not exist. Only then, only at the price of every familiar thing, do the stars finally come close enough to stroll between. Even light slows to a crawl on this sidewalk. On the coin scale, a beam of light crosses the coin, the whole solar system, in about 8 hours. One coin, one working day. The speed limit of the universe spends a full shift just clearing the sidewalk's smallest object, and then faces the block. So this is the new territory and its new rules. Stars are coins. The space between them is measured in football fields of empty pavement. Whole planetary systems are the small change of the universe, scattered thin across a very long street. The obvious next question is how many coins there are, and how much street. Let's start counting the neighbours. Scatter the change. Our coin lies on the sidewalk, and 350 feet down the block sits Proxima. Proxima does not live alone. It belongs to a family of 3 stars called Alpha Centauri. 2 bright suns circling each other closely with little Proxima swinging wide around the pair. So at the end of your first walk, you actually find a small cluster of coins together. That triple system is our closest neighbour in the entire universe. Our next door address. Keep walking, and the neighbourhood slowly reveals itself. About 500 feet from home, in another direction, lies Barnard's star. A dim red coin, completely invisible to your naked eye at night, despite being the second closest system we have. Around 700 feet out sits Sirius, the brightest star in Earth's night sky. The big dog star that every stargazer in the Northern Hemisphere knows on sight. And even that celebrity is 2 football fields of empty sidewalk away from our coin. with nothing in between. Now widen out and take the census. Within about 10 light years of the Sun, which on our model means within 1/5 of a mile of our coin, there are roughly a dozen star systems, a dozen coins, spread across an entire neighbourhood of streets. Everything else in that neighbourhood, every yard of every block in every direction, is vacuum. This is where another childhood picture has to go. Every illustration of a star field you have ever seen, every movie, shot of a ship gliding through swarms of stars, has planted the idea that stars live close together, packed like city lights seen from a plane. The night sky itself pulls the same trick, because it flattens 3 dimensions into 2, pasting stars that are wildly far apart onto the same black ceiling, shoulder to shoulder, as if they were neighbours. They are not neighbours. Each of those points of light is a coin with football fields of nothing around it in every direction, and the crowding is an illusion of the flattening. Here is the test that proves how empty it really is. Whole galaxies sometimes crash directly into each other. Hundreds of billions of stars plunging through hundreds of billions of stars. Astronomers have modelled these collisions in detail, and the models all agree on something that sounds impossible. When 2 galaxies collide, essentially no stars hit each other. The 2 swarms pass through one another like 2 clouds of gnats. Coins gliding between coins, football fields to spare on every side. The most violent event in the life of galaxies is, at the level of individual stars, a non-event. Remember that, because in 3 chapters that exact fact is going to come back with our own galaxy's name on it. That is the true texture of the region we live in. From inside it, on a dark night, it looks rich and full and close. On the honest model, it is coins on pavement, one every few blocks, patient and separate, each one holding its microbe of a sun and its invisible dust of planets. Each one wrapped in its own private district of nothing, a dozen systems within 1/5 of a mile, 1,000 or so within a mile. The counting has begun, and it feels manageable, the way every level of this journey has felt manageable at the start. So here is the question that ends the manageable part. Our coin, Proxima's coin, Sirius, Barnard's star, all of it belongs to a single larger structure. One vast spinning collection of coins called the Milky Way galaxy. We are about to ask how much sidewalk the whole collection needs. I will tell you now, the sidewalk does not survive the answer. Every model we build eventually meets something too big for it. The grain of sand met Proxima Centauri and ended in a field outside Denver. Now it is the coin's turn. The Milky Way is our galaxy, the full structure that our sun belongs to, a flat spinning disk of stars, gas, and dust, turning slowly in the dark. Astronomers estimate it holds at least 100 billion stars, and the true count may run several times higher. For scale purposes, take the cautious floor. 100 billion coins. The disk they form measures at least 100,000 light-years across. On the coin model, where the gap to Proxima was a football field, here is what 100,000 light-years becomes, about 1,600 miles. With our solar system as a quarter lying on a sidewalk in New York City, the Milky Way is a disk of coins stretching from that sidewalk past Chicago, past the Mississippi, across the Great Plains, all the way to Denver. I chose those cities deliberately, and some of you already hear the echo. In Chapter 8, on the old model, New York to Denver was the distance to a single star. One gap, one neighbour, the loneliest drive in the universe. We then shrank the entire solar system by a factor of thousands to defeat that drive, and the galaxy just handed it right back. Same road trip, same interstates, same plains, same mountains at the end. Except this time the road is not crossing the gap between 2 stars. This time, every few blocks of that 1,600-mile drive, there is another coin, another star system, Another sun. Another possible family of worlds. Block after block. County after county. State after state. From the Atlantic seaboard to the Rockies. That is one galaxy. That is what 100 billion looks like when you spread it honestly. The disk is thin. 2. Which surprises people. For all its width. The Milky Way's star-filled disk is only about 1,000 light-years deep in our region, which on the model comes out to roughly 15 miles. A structure 1,600 miles across and 15 miles thick. Those are the proportions of a pancake. And that is the actual technical picture astronomers work with. A vast, luminous pancake of coins spinning in the black. Now find us. It is a human instinct to assume we sit somewhere important. And the map does not cooperate. The Sun lies about 26,000 light-years from the galactic centre, which, on our coin model, puts us roughly 400 miles out from downtown, in a modest spiral arm segment called the Orion Spur, a side street between two grander avenues. We are not in the bright, crowded core. We are not out on the lonely rim. We live in the galactic equivalent of an unremarkable middle suburb, on a quiet block, circling a microbe-sized sun, invisible at virus scale, 400 miles from anything you could call the action, and the whole structure is moving. The sun, carrying all its planets with it, orbits the centre of the Milky Way at about 500,000 miles per hour, and even at that speed, one single lap takes around 230 million years. The last time our solar system occupied its current position on the galactic map, the dinosaurs were just getting started. The entire age of the dinosaurs. Their rise, their 160 million year reign, and their extinction, plus the whole age of mammals, plus every second of human existence. All of it fits inside one lap of the track we are on right now. Let the yardsticks finish the job. Light, which crossed our coin in 8 hours, needs 100,000 years to cross the galaxy. The beam arriving from one edge left when our ancestors were sharing the planet with Neanderthals. And Voyager 1, our 50-year champion, the most distant machine we have, would need close to 2 billion years to make the same crossing. 2 billion years ago. The most advanced life on Earth was pond scum. Aim Voyager across the galaxy today. And by its arrival, whatever meets it will have had time to evolve from bacteria into whatever comes after us. So stand back from the map and see where 11 chapters have left us. The Earth is a virus on a quarter in New York. The nearest star is down the block, and the city of coins runs west for 1,600 miles. 100 billion strong. One every few blocks, all the way to the Rockies. 100 billion of anything sounds crowded. It sounds like a mob, like standing room only, like a galaxy stuffed to the rafters with stars. The next chapter is about why that is exactly backwards, and why the darkness of your night sky is the proof. 100 billion stars. Let the number do what it wants to do in your head. It wants to build a wall of light, a galaxy packed edge to edge. Stars, elbowing stars for room. Every painting of the Milky Way encourages it. Every movie flyover. Every video game skybox. Every glossy magazine spread shows the galaxy as a blizzard of light. Dense as static. Thick as snowfall. Now, run the actual arithmetic, because we have all the pieces on the sidewalk already. 100 billion coins, spread across a disk 1,600 miles wide and 15 miles thick. That sounds like it should carpet the pavement. Divide it out honestly, coins into volume, and the average patch of galaxy gets 1 coin for every few blocks of empty street, in every direction, including up and down. That is not a blizzard. That is a country where every town owns a single streetlight, and the towns are not close together. Here is the number stated cold. In our region of the Milky Way, the typical distance between neighbouring star systems runs 4 to 6 light-years. The gap between our Sun and Proxima Centauri, the gap that broke our first model, the road trip past Denver, is not some freakish local emptiness we happen to live in. It is normal. It is the standard spacing, 100 billion times over. Star, gap, star, gap. Each sun wrapped in its own trillions of miles of private vacuum, all the way across the disk. The galaxy is not a crowd. The galaxy is the same loneliness we discovered in Chapter 8. Mass-produced. You want proof you can check tonight? Without a telescope, without leaving your yard. Go outside after dark and look up at the black between the stars. Now imagine the paintings were true. Imagine our galaxy really were packed the way the illustrations show it. Stars shoulder to shoulder, wall to wall. In a galaxy like that, nearly every line of sight from your eye would run into a star before it ran out of galaxy. The way every sight line in a thick forest ends at a tree trunk. The night over your head would glow in every direction. The actual sky does nothing of the kind. At the scale of our own galaxy, all that darkness is telling you how little of any sightline ever touches a star. Corridor after corridor of nothing, running on for trillions of miles behind the frame. You have been looking at the evidence your whole life. It was hiding as the background. The emptiness even keeps the galaxy running on schedule. All 100 billion of those stars are moving, each one tearing along its orbit at hundreds of thousands of miles per hour. A freeway with 100 billion vehicles and no lanes. No lights. No driver in any of them. That system should be carnage. It is the calmest place there is. Collisions between stars are so fantastically rare that our galaxy can run for billions of years without two of its stars meeting. Because at coin and football field spacing, there is simply nothing to hit. The gaps are the insurance policy that lets 100 billion stars share one structure forever. Unsupervised. Without incident. So file the true portrait of the Milky Way. The one no artist will ever paint because no customer would ever buy it. A pancake of vacuum, 1,600 model miles wide. Seasoned. Sparsely. With 100 billion isolated sparks. Each spark alone, in a cell of darkness, bigger than the entire solar system by orders of magnitude. Crowded is the last word it deserves. And now this journey has a familiar problem. One level higher. The coin model is straining. You can feel it. It needed a football field for one gap. A continent for one galaxy. The next landmark on our map is another galaxy entirely. And on the coin scale, reaching it means leaving the planet. There is no sidewalk long enough. The model that swallowed the Milky Way cannot take one more step. So we do the thing we do. We shrink again. Harder this time. And this next compression is the most brutal one yet. We are about to take the pancake. The 1,600 miles. The 100 billion coins. The whole galactic city from New York to Denver, and crush it down to something that fits on your kitchen table. We are going to turn the Milky Way into a dinner plate, and then we are going to meet the neighbours. Take the galaxy, all of it, and press. The disk from New York to Denver. Press. The 100 billion coins. Press. Every star you have ever seen in every night sky of your life. All of it. Down, down, until the whole Milky Way is a glowing dinner plate 10 inches across. Sitting on your kitchen table, we are back where this journey started. Back in the room with the table. Except the object on the table now is not a grain of sand. It is everything. On this plate, the sun and every star visible to your naked eye huddle together inside a single fleck of glaze. The solar system has no size worth stating. The Earth has been unprintable for 2 models now. The plate is the new minimum unit. Galaxies are the objects now. So the question writes itself, where is the next plate? After everything this journey has done to us, you have earned the right to expect the worst. The last 2 times we asked where is the next one, The answer wrecked the model. The nearest star needed a continent. The galaxy needed another continent. So the nearest galaxy should need what? The Moon. Here is the actual answer. And after 12 chapters of escalation, it is the twist nobody sees coming. The Andromeda Galaxy. The nearest major galaxy to our own. A spiral even larger than the Milky Way. Sits about 2.5 million light-years away. Enormous. Yes, the light making that trip left before our species existed. And we will come back to that. But put it on the model. With the Milky Way as a 10-inch dinner plate, Andromeda is a slightly larger plate, sitting about 20 feet away. Across the room, read that again slowly. 2 plates. Opposite sides of a modest living room. That is the honest map of the 2 great galaxies of our neighborhood. Something just changed in the deep grammar of the universe. And I want to make sure it lands. All journey long. The gaps have dwarfed the objects. The sun sat 40 feet from a 1 millimeter grain. A gap 40,000 times the object. Proxima sat a football field from a 1-inch coin. A gap thousands of times the object. Every rung of the ladder taught the same brutal ratio. Tiny things. Oceanic spacing. And now, at the largest scale yet, the pattern breaks. A 10-inch plate. 20 feet from another plate. The gap is only about 25 times the object. On the map of galaxies, for the first time anywhere in this story, things are close together. Galaxies live within reach of each other, near enough to touch one another with their gravity. And that nearness is about to matter, because the 2 plates are not sitting still. Measure Andromeda's motion, and you find it is coming toward us at about 250,000 miles per hour. The gap between the plates is closing, and for decades, the story astronomers told about that closing gap was simple and dramatic. Sometime around 4 or 5 billion years from now, the Milky Way and Andromeda would collide head-on, merge, and become one giant galaxy. It was in the textbooks. It was in the documentaries. It was treated as an appointment, already on the calendar. Then the measurements got better, and the appointment got interesting. A head-on collision only happens if Andromeda is flying almost straight at us. If it also has enough sideways motion, the 2 galaxies swing past each other instead, and that sideways drift is brutally hard to measure across 2.5 million light-years. In 2025, a team of astronomers combined the best data from the Hubble and Gaia space telescopes, ran the encounter thousands of times, with all the uncertainties included, and published a result that quietly rewrote the textbook. The chance that the 2 galaxies actually merge within the next 10 billion years came out close to a coin flip. 50-50. And the classic version, the head-on crash in 4 or 5 billion years, dropped to only about a 2% chance. The most famous collision in astronomy is now an open question, being refined right now. By measurements still coming in, here is the part that survives either way, and it is the payoff I planted 3 chapters ago. Whether the galaxies merge on the first pass, or dance around each other for billions of years first, or slide past and take the long way, the fate of the individual stars is the same. Essentially, none of them will ever touch. Coins gliding between coins. Football fields to spare. 200 billion stars can pass directly through 200 billion stars, and star by star, it is a quiet night. The emptiness we spent 13 chapters measuring is the reason the biggest event on our galaxy's calendar, if it comes at all, is survivable. Now, the light. I promised we would come back to the 2.5 million years, because there is a human moment buried in it, and it is one of the great nights in the history of looking up. For most of history, Andromeda was just a faint smudge in the autumn sky, one you can still find tonight with your naked eye from a dark field, the most distant thing human vision can catch unaided. Astronomers assumed the smudge was a small cloud of gas inside our own galaxy, because our own galaxy was as far as anyone knew, the entire universe. Then, in October of 1923, at the Mount Wilson Observatory in the mountains above Los Angeles, a young astronomer named Edwin Hubble aimed the largest telescope on Earth at the smudge and photographed a tiny flickering star inside it, a type whose flicker rate reveals its true distance. Hubble ran the numbers, crossed out his first guess on the photographic plate, and wrote 3 letters next to the star, V-A-R, with an exclamation point. That flicker put Andromeda far outside the Milky Way, impossibly far outside it. And with that one measurement, the known universe stopped being one galaxy and became, as we now know, a universe of billions of them. A man with a pencil, on a mountain outside Los Angeles, and the universe was never the same size again. The light Hubble measured had been travelling for about 2.5 million years. When those photons left Andromeda, our species did not exist. The early members of the human line were living in Africa, just beginning to work with stone tools, and the photons flew through the entire span of human evolution, start to finish, and arrived at a mountaintop in California just in time to be caught by a species that had invented the telescope only 3 centuries earlier. Every photon from Andromeda that lands in your eye tonight carries the same itinerary. That is what 2.5 million light-years means when you measure it in becoming. 2 plates. 1 room. 1, maybe someday merger that the stars themselves will barely notice. And here is the closing question. The same one as always. 1 level up. If galaxies are the new objects, and galaxies come in pairs and pockets, what do the plates themselves belong to? Set more places at the table. The neighbourhood is bigger than 2. The room with the 2 plates has a name. Astronomers call it the local group, and it is our home at the newest level of the map, the full gravitational household that the Milky Way belongs to. Let's furnish it properly. 2 great plates dominate the room. The Milky Way and Andromeda, 10 inches and 12, facing each other across 20 feet. 1 more respectable dish belongs to the set, a spiral called triangulum, smaller than the big 2, a side plate a few feet from Andromeda, and around and between the 3 of them, scattered across the whole room, floor to ceiling, there are dozens of smaller things, saucers, buttons, crumbs of porcelain. These are the dwarf galaxies, small, ragged collections of a few million or a few billion stars each, and the local group holds dozens of them that we know of, with fainter ones still being discovered. Some are satellites, circling the great plates the way moons circle planets. 2 of them, the Magellanic Clouds, hang close enough to our plate that from Earth's southern hemisphere you can see them with your naked eye. 2 soft, glowing patches in the night, whole separate galaxies, visible from your backyard, orbiting ours, the whole household, plates and saucers and crumbs together, spans about 10 million light-years, which on the dinner plate model comes out to a room roughly 80 feet across. A big room, a small banquet hall, holding everything, somewhere between 50 and 100 galaxies, bound to each other by gravity, falling and swinging around one another in a dance that has been running since before the Earth existed. And now do the thing this journey has trained you to do. Find us. Find home in the banquet hall. The Milky Way is 1 plate among dozens of dishes. On that plate, the sun is lost inside a single fleck of glaze, along with every star any human has ever seen. Inside that fleck, at a size 2 full models below anything visible, below the coins, below the viruses, is the planet this entire story is named after. Chapter 1 gave Earth a whole beach. Chapter 15 gives it this: a nothing, inside a fleck, on a dish, in a hall of dishes. Hold the hall in your mind for a second, because there is a quiet pattern in the ladder we have climbed, and this is the place to see it whole. Look at how the meaning of the word object has kept moving under our feet. In the first act of this story, objects were planets, and stars were the gods above them. In the second act, objects were stars, coin en pavement, and galaxies were the cities that contained them. Now, in the third act, objects are galaxies. Whole 100 billion star structures have become the individual things, the units, the dishes on the table, and the next structures up, the groups and clusters, are becoming the containers. 3 times the universe has demoted an entire category of giants into furniture. Planets became invisible. Then stars became invisible. Now galaxies are becoming mere pieces. Keep that pattern in hand, because it has one more turn in it. And the last turn is the biggest one, because the banquet hall has walls, and the walls have windows. And the obvious question is standing at the glass. What is outside the room? Is the local group the end of structure? A lonely household adrift in infinite black? Or are there other rooms? There are other rooms, about 55 million light years from us, which on our model is a quarter mile from the banquet hall, stands a structure that makes our entire local group look like a closet. The Virgo cluster, well over 1,000 galaxies, packed into one gravitational metropolis, plates stacked on plates, a downtown of galaxies whose combined pull is strong enough that it tugs measurably on our whole household, on every dish in our room. From a quarter mile away, our banquet hall, it turns out, is a farmhouse, on the outskirts, in the gravitational countryside, and the countryside itself, the full landscape that farmhouses and metropolises both sit in, has a shape, a real, mapped, physical shape, and it is not what anyone expected. The galaxies of the universe are not scattered evenly through space like stars in the old paintings. They gather into something else entirely, something with threads and knots and enormous hollow places, something that, when astronomers first charted it, looked less like a map of the sky and more like something alive. The last model of this journey is about to reach its limit. What replaces it is the true shape of the universe. Through the whole 20th century, if you asked an astronomer what the universe looked like at the very largest scale, most would have given you the same reasonable answer. Galaxies everywhere, spread more or less evenly, like dust in a sunbeam. A few clumps here, a few gaps there, but overall, smooth. Sprinkle galaxies through space the way you salt a steak. That was the expectation, and it was never based on a map, because no map existed. Making one meant measuring the distance to thousands of galaxies, on a beyond, and that work only became possible in the late 1970s and 80s, so astronomers started measuring, plotting each galaxy as a dot in 3-dimensional space, slice by slice of the sky. And as the dots accumulated, the picture that emerged stopped a lot of people cold, because the dots refused to spread evenly. They gathered, they lined up. Thousands of galaxies strung themselves into immense glowing threads. The threads wove into sheets and walls. The walls met at dense knots, and between all of it stretched enormous rounded hollows with almost nothing inside. One of the first great survey maps drew a pattern so unmistakable that a researcher could point at the wall of galaxies running across it, shaped like a human figure with arms spread, and everyone saw it instantly. The universe had a texture, and the texture looked familiar in a way nobody was prepared for. It looked like a web. It looked like foam. It looked, uncomfortably, like the inside of a living thing. That structure now has a name, the cosmic web, and as far as our deepest surveys can map, it is the largest architecture there is. Picture a sponge, or a mass of soap bubbles, scaled beyond all reason. The soap film is where the galaxies live, sheets and filaments of them, millions of light years long. Each filament a highway of thousands of galaxies streaming under gravity. The knots where filaments cross are the great clusters, The metropolises like Virgo, thousands of plates piled into a few million light years, and the inside of each bubble is a void. That word is doing real work. A cosmic void is a region tens of millions, sometimes hundreds of millions of light years across, containing almost no galaxies at all. Emptiness at a scale that swallows every other emptiness in this story whole. Let one void stand for all of them. Out in the direction of the constellation, Boots lies a hollow about 330 million light years across, one of the largest nothings ever charted. To feel that size, remember Chapter 14, the gulf between the Milky Way and Andromeda. The gap light needs 2.5 million years to cross, the distance that contains the entire evolution of our species. The Boots void is over 100 of those gulfs, side by side, in every direction, with a few scattered dozens of galaxies rattling around inside where a normal patch of universe would hold tens of thousands. One astronomer put it in a sentence that has never been topped. If the Milky Way sat at the centre of the Boots void, we would not have known other galaxies existed until the 1960s. The whole discovery Hubble made on Mount Wilson in 1923, the night the universe multiplied, would have been physically out of reach for decades longer, because the nearest plates would have been too far away for early telescopes to resolve. There are addresses in this universe where the universe itself is hidden. Our own address sits in the web too, and it has recently been mapped with real precision. In 2014, a team of astronomers charted the motions of thousands of galaxies around us, watching which way each one drifts, and found that our whole region flows like water in a landscape. Galaxies streaming down gravitational slopes toward common basins. The basin we belong to spans about 500 million light years and contains the mass of roughly 100,000 galaxies. And they named it Laniakea, a Hawaiian word meaning immense heaven. Be careful with what that name refers to, because headlines mangled it. Laniakea is a watershed, the full territory whose galaxies all drain toward the same deep point, the way a river basin is defined by where its rain flows. There is no wall around it, and you could never photograph it from outside. Our local group, our whole Bonnke Hall, is one droplet in the Laniakea flow, riding one tributary, out near the edge of the basin. And now you can see for yourself that the dinner plates are finished. Look at what this chapter would demand of them. The plates were galaxies, and the banquet hall was 80 feet. Virgo was a quarter mile away. To contain Laniakea, the model needs about 2 miles of space in every direction, a sphere swallowing your whole neighbourhood, filled with 100,000 dishes arranged in threads and sheets. To contain the Boots void alone, an empty bubble more than a mile wide with nothing in it. The grain of sand needed a continent and failed. The coin needed a continent and failed. The plate now needs your entire town. And I'm not going to build a fourth model, because there is no fourth model. Every scale model in this story worked by shrinking the universe until it fit beside something human. A table, a sidewalk, a room. There is nothing human left to stand beside. From here forward, the only honest instruments are the ones astronomers themselves are stuck with. Light and time. And the only honest statement of size is how long light takes. So this is the final landscape. Stated plainly, galaxies gather into groups. Groups stream into clusters. Clusters chain into filaments millions of light years long. Filaments weave into a web that spans the entire visible universe, wrapped around voids of almost perfect nothing, and out at the largest distances we can chart. The web is where structure ends and the universe evens out into sameness, which leaves the final count. We have been promoting units all journey, planets to stars to galaxies, and the galaxies are now threads in a web. So how many are there? How many galaxies exist in the whole visible universe? Here is the strange truth about that number. Nobody reasoned their way to it. It was not derived on a whiteboard. It came from a photograph. One single photograph. and the photograph almost did not get taken, because the man who ordered it was gambling the most famous telescope in history on 10 days of pointing at absolutely nothing. By 1995, the Hubble Space Telescope was the most famous scientific instrument on Earth, and it had earned that fame the hard way. It had launched in 1990 with a flawed mirror, becoming a late-night punchline and a national embarrassment. A billion-dollar telescope that could not focus. Then astronauts flew up in '93, installed corrective optics and a series of spacewalks watched around the world, and the pictures that followed were suddenly the sharpest views of the universe ever taken. The telescope had gone from disgrace to treasure in one repair, and now every astronomer alive wanted time on it. Observing hours were rationed like water in a drought. Committees fought over single orbits. Every minute was supposed to be pointed at something that guaranteed results. The director of the institute that runs Hubble was an astronomer named Robert Williams, and the director held a rare privilege, a personal allocation of telescope time, a slice reserved for the director's own judgment, to use on whatever he saw fit. Williams decided to spend essentially all of his on one idea, and the idea sounded like a joke. He wanted to point the most oversubscribed telescope in the world at nothing. He asked his team to find the emptiest available patch of sky, a spot with no bright stars, no known galaxies, no gas, no anything, and they chose a speck of blackness near the handle of the Big Dipper, a patch so small that a grain of sand held at arm's length would cover it, and Williams proposed to aim Hubble at that empty speck and hold it there. Exposure after exposure, orbit after orbit, for 10 consecutive days. Colleagues told him, in so many words, that he was about to waste the most precious observing time in science. The reasonable prediction was that deep space between the known galaxies was simply dark, and that 10 days of staring would return a black rectangle, and the black rectangle would arrive with the telescope's reputation freshly repaired and Congress watching the program closely. Williams understood the stakes, and he has said since that if the frame came back empty, he expected to answer for it personally. He gave the order anyway. On un simple argument. Nobody had ever looked. Every great leap in astronomy had come from looking harder at something that seemed empty, and the one guarantee was that if nobody took the exposure, nobody would ever know. So for 10 days across Christmas of 1995, while most of the country was on holiday, Hubble circled the Earth staring at a keyhole of nothing, 342 separate exposures of the same tiny black patch, and the team stacked them into a single image, and then they looked at it. The picture was not black, it was full, corner to corner, edge to edge. The empty patch was crowded with galaxies, big, bright spirals, faint red smudges, warped shapes mid-collision, blue sparks of newborn galaxies, dim ellipticals like distant lamps in fog, over 3,000 of them, in a piece of sky the size of a sand grain at arm's length, a piece chosen specifically because it appeared to contain nothing at all. Nearly every object in the frame was an entire galaxy, a whole dinner plate, hundreds of billions of stars, and they went on, deeper and fainter, down to the very limit of the exposure. The image was released to the public in January of 1996 as the Hubble Deep Field, and it is one of the most consequential photographs ever taken. And it changed the census of the universe in one stroke, because the patch was chosen for its emptiness. It could not be special. That was the entire logic. Whatever showed up in that random keyhole had to be typical of every keyhole, and that permits a piece of arithmetic that should raise the hair on your arms. Measure the patch, count the galaxies, and multiply across the full sky, and the answer comes out in the hundreds of billions of galaxies in the observable universe. Later, deeper surveys push the count upward, and some analyses argue the true number, counting the smallest faint dwarfs, runs into the trillions. Hold the conservative floor, and it is still beyond taming. hundreds of billions of galaxies, each one a plate of hundreds of billions of stars. And if you want the full multiplication, the stars of the observable universe outnumber, by most estimates, every grain of sand on every beach and every desert on Earth. One photograph did that. 10 days of nothing, ordered by one stubborn astronomer against sensible advice. And the reward was the head count of creation. There is one more thing hiding in that image, and it is the doorway to our final chapters. Look closely at the deep field and you notice the galaxies are not all the same age. The nearer ones look settled and grand. The farthest ones look small, ragged, half-formed, because their light spent billions of years in transit, and the picture shows them as they were when the light departed, in the universe's chaotic youth. Chapter 9 planted this key, and here is the lock it opens. Distance and delay are the same thing. That photograph is not a map of space. It is a core sample of time, layer behind layer, reaching down toward the beginning. And that means the counting has a wall. We did not count the universe. We counted the part of the universe whose light has managed to arrive, which forces the last question of this journey. And the biggest. How far does the light reach? How large is the visible part? The whole sphere of everything any telescope could ever see. There is an exact answer, and it is stranger than any number so far, because the universe is 13.8 billion years old, and the visible sphere is 93 billion light-years wide. And I know how those two numbers sound sitting next to each other. They sound like a mistake. They are not a mistake. Every measurement in the deep universe eventually leans on one fact. So let's plant it firmly. The universe has an age. It began, as far as all our evidence shows, 13.8 billion years ago, in the event we call the Big Bang, and everything since, every star, every galaxy, every atom in your body, has happened inside that span. 13.8 billion years is the total running time of everything. That age seems to hand us the size of the visible universe for free. And here is the reasoning everyone runs on first pass. We see by light. Light has a speed limit. If the universe is 13.8 billion years old, then no light has had more than 13.8 billion years to travel. So the farthest thing we could possibly see should be 13.8 billion light-years away. The visible universe should be a sphere about 27 billion light-years across. End to end. Clean. Logical. Done. And it is wrong. And the actual answer, the one in the textbooks, is that the observable universe is about 93 billion light-years across. The farthest things we can see are 46 billion light-years away, sitting in a universe not even 14 billion years old. And I have watched that pair of numbers break people. It sounds like the universe got caught cheating, like something outran light, like the math has a hole in it. This chapter exists to close that hole properly, because the resolution is one of the most beautiful facts in all of science, and it deserves better than a hand wave. Here is the fact that fixes everything. Space itself is expanding. That statement gets said so often it slides past people. So let me pin down what it actually claims. It does not claim that galaxies are flying apart through space, like shrapnel from an explosion into a waiting emptiness. It claims something stranger. The distances themselves are growing. The gap between any two far separated points in this universe is physically larger today than it was yesterday, because new distance is continuously coming into existence between them. Galaxies are not so much travelling apart as being carried apart, riding a fabric that stretches everywhere at once. Edwin Hubble, the same man from the mountain in Chapter 14. They found the first evidence of this in 1929, when he measured that essentially every distant galaxy is receding from us, and that the farther away a galaxy lies, the faster it recedes. Exactly the pattern you get when the space between everything is uniformly swelling. Now watch what that does to a beam of light on a long trip, because this is the whole answer. Picture a photon leaving a young galaxy over 13 billion years ago, aimed at the spot where the Milky Way would one day form. When it departs, its target is only a few billion light years away. A long trip, but a defined one. The photon flies at full speed, never slowing, never pausing. And while it flies, the road stretches. Every year of the journey, the space behind it grows. The space ahead of it grows. The entire highway lengthens under its feet in both directions. The photon keeps gaining ground, and the ground keeps being manufactured. If you want the feel of it in your body, here it is. You are walking down one of those moving walkways at the airport, except this one is running backward against you. And, stranger, the walkway itself is also growing longer while you walk. New belts spooling into existence along its whole length. You still make progress. You do eventually reach the far end, but when you turn around and look back, the walkway behind you has been stretching the entire time you walked it, and the gate you started from is now vastly farther away than the distance your legs ever covered. Your legs walked one distance, the stretching built another, and both are real. That is precisely the situation of the oldest light reaching our telescopes tonight. The photons themselves have honestly travelled for up to 13.8 billion years, never once breaking the speed limit. But the galaxies that sent them have spent those same billions of years being carried away by expansion, and the space crossed early in the trip has itself kept stretching ever since. Run the full accounting, the travel plus the stretching, with the expansion history that our measurements give us, and you get the true present-day distance to the farthest visible material, about 46 billion light-years, in every direction, a sphere of everything we could ever see, 93 billion light-years side to side, wrapped around one unremarkable galaxy, in one filament of the web, where a virus-sized planet holds the only known astronomers. And notice, no rules were broken to get there. Nothing ever outran light through space. Light wins every local race it enters. What the speed limit never governed is the stretching of space itself, because that limit applies to things moving through the universe. And expansion is not a thing moving through the universe. Expansion is the universe. Distant galaxies can be carried away from us faster than light without violating anything. The way two dots on an inflating balloon separate without either dot crawling anywhere. The cosmic speed limit stands. The cosmos just grows underneath it. So here, at last, is the full architecture, the complete answer to the question this video is named for, stacked in one breath. The Earth. 3 miles of horizon. 2 weeks to drive around. Lost beside the sun. The sun, one grapefruit, lost on a 1/4-mile walk of planets. The planets, lost on a 2,000-mile drive to the nearest star. The stars, quine on pavement. 100 billion of them, lost in a galaxy the size of a continent. The galaxy, one plate, 20 feet from its twin, lost among the dozens of its household. The household, lost in the web, one droplet of Laniakea, threads and voids weaving outward through hundreds of billions of galaxies, to the edge of a sphere 93 billion light-years wide. That is the measured, mapped, evidence-backed answer. That is the true scale of the universe, except for one word. There is a single word in that answer that I have been using carefully for 2 chapters. And if you noticed it, you may already feel the floor shifting. The word is observable. The 93 billion light-years is the size of the observable universe. I never said it was the size of the universe. Nobody can say that. And the reason nobody can say it is the last door in this story. The word observable is doing a very specific job. And the job is honesty. Think about what actually defines that 93 billion light-year sphere. Nothing physical. There is no wall out there. No boundary marker. No place where the galaxies stop. The edge of the observable universe is defined by one thing only: the age of the light that has managed to reach us. We can see 46 billion light years in every direction, because that is how far away the material is whose light, launched at the beginning of time and riding the expansion ever since, has just now, today, completed the trip to Earth. The sphere is the size of our mailbox. It contains every letter that has had time to arrive, and here is the detail that should quietly rearrange your picture of everything. That sphere is centered on us, perfectly. We sit at the exact middle of the observable universe. And for once, being at the center means nothing at all, because everyone is a galaxy 10 billion light years from here, sits at the center of its own sphere of arrived light. A sphere that includes territory we will never see, and excludes territory we see every night. Every point in the universe wears its own private bubble of visibility, and no two bubbles match. Observable is a point of view, and every place in the cosmos has one, so the real question stands outside the bubble, past the farthest galaxy any telescope will ever record, past the oldest light. What is there? How much more universe exists beyond the reach of our mail? Here is the honest inventory of what science can currently say, and it is short. We do not know how big the whole universe is. We do not know whether it is finite or infinite. Those are the actual limits of human knowledge in the 21st century. Stated plainly, the universe could close back on itself, the way the surface of the Earth does, so that a traveller holding a straight course for long enough would someday come around from the other side. Or it could simply continue forever. Galaxies and filaments and voids without end, in which case the word size does not even apply to it. Both possibilities remain fully open. Our best measurements offer one clue, and it cuts in an interesting direction. Cosmologists can test the overall geometry of space, checking whether the fabric of the universe bends on the largest scales, and every measurement we own comes back the same way. Flat as our instruments can measure, with no detectable curve at all. Now, flatness alone does not settle the question, because a flat universe can still be finite, folded up in ways that leave no local bend. And an infinite universe is flat by definition. What the flatness does tell us is this: if the universe curves at all, the curve is so gentle that the whole must be enormously larger than the piece inside our bubble. Some analyses put the minimum at hundreds of times the width of everything we can see. The ceiling is unknown, and there may be no ceiling. There is also a version of this fact with a clock attached, and it changes what the observable universe will mean to the people of the far future. The expansion of space is accelerating. The distances are growing faster every year, and that has a consequence for the mail. Galaxies beyond a certain distance are being carried away so quickly that their newest light will never complete the trip to us. The road between us is lengthening faster than light can close it, and one by one, over the deep future, distant galaxies will slip past that point of no return. Their old light will keep arriving for ages, fading and stretching, but the sky of the far future will hold fewer reachable galaxies than the sky of today. We are watching the show during the act when the most of it is visible. Be careful with what all this does not say. Though, it does not make the universe mysterious in some hand-waving way, and it licenses no wild stories. Everything inside the bubble is measured, mapped, cross-checked, real. The web, the count, the 93 billion, all of it stands on evidence. The only claim this chapter adds is a boundary claim, and it deserves one clean statement. So here it is. The 93 billion light-year universe is not the universe. It is simply the portion from which light has had time to reach us. It is the size of our window. It is not the size of the world. So the journey ends at glass. 18 chapters of travel, 3 dead models, a ladder of grains and coins and plates, and the Picop rung turns out to be a windowsill, with an unmeasured remainder on the far side keeping its own counsel. Science walked us here, handed us the number, and admitted where the number stops, which leaves exactly one measurement left to take. We spent this entire journey asking how big everything else is. We never went back to check on the thing we shrank first. It is time to collect the Earth. Go back to the beach. Same coast. Same early morning. Same person standing at the waterline. Nothing has moved. The Pacific still runs to the horizon, and the horizon is still 3 miles out, and everything beyond it still hides behind the curve of the world. The jet to Tokyo still takes 11 hours. Texas still takes all day. The planet still measures 25,000 miles around. And if you tried to drive it, it would still take 2 weeks without sleeping. And it would still be the hardest trip of your life. Check the numbers from the far end of the journey. And they hold too. The Earth is still 7,926 miles wide at its equator. Every inch is accounted for. Every mountain kept its height. Every ocean kept its depth. Through 18 chapters of shrinking, through the grain and the virus and the vanishing. The actual planet sat here the entire time, fully sized, completely unbothered, carrying its 8 billion people through an ordinary morning. Because here is the plain truth about everything you just watched. We never shrank the Earth. We only kept finding bigger things to stand it next to. The grain of sand was never the planet. It was the planet next to the sun. The virus was the planet next to the galaxy. The unprintable nothing was the planet next to the web. Every model in this story was a comparison. And a comparison takes two. And the second thing kept growing until no room. No sidewalk. No continent could hold it. The Earth never changed. The company changed. And that is worth getting exactly right. Because the usual lesson people draw from journeys like this one is the wrong lesson. The usual lesson is smallness as defeat. The shrinking planet. The meaningless speck. Run the actual tape back and watch what really happened. A 3-mile horizon measured 100,000 light-years of galaxy. A species that needs 11 hours to cross one of its own oceans counted the galaxies of the observable universe from a photograph of nothing. Somebody standing on the grain figured out the grapefruit. Somebody on the virus mapped Laniakea. Somebody inside the fleck of glaze on one plate in the banquet hall worked out that space itself is stretching, and proved it, and measured the stretch. Every number in this story, every distance that outgrew every model, was discovered from here. The window is 93 billion light-years wide, and the entire window was measured from a beach town's worth of observatories on a world too small to draw. The scale of the universe is not a verdict on the Earth. It is just the view. So stand at the waterline one more time and look out at the 3 miles you are given. Somewhere overhead, too faint to notice in the morning light, Proxima Centauri is sending its 4-year-old news. Andromeda's photons are arriving from a departure 2.5 million years back, finishing their trip in the eyes of whoever bothers to look up tonight. The web holds its threads. The voids hold their silence. The window holds everything we will ever see. And past the glass, an unmeasured remainder waits. Patient, unhurried, under no obligation to ever be known. The Earth did not get smaller on this journey. It was always exactly this size. All we did was finally find things large enough to compare it with. And even that comparison ends at the edge of what we can see, not at the edge of what there is.